Hello guys, from today onwards, I am going to start a new series. I will pick up the questions from LeetCode and GFG portals, and these are the questions which are in which most of the students face difficulties, and I will try to explain all these questions uh, from 100% of my effort. I will put my 100% effort to explain the solution of all these questions, and I will try to keep the solution as simple as possible. And every questions I will follow a certain kind of pattern. First of all, I will go through the questions. Then I will discuss the solution of the questions. That means I will write the pseudocode or I will discuss the pseudocode. Then after that, I will write the brute force approach. And after that, I will write the code. And if I will find it difficult for you to understand the solutions, uh, I will make a dry run, and I think that dry run is what which makes the concept clear. And I will recommend you all to uh, dry run the questions, even if you are not understanding the solutions of any questions, any DSA questions. When you will dry run, you will actually know the internal working, or you will get very basics. And if you keep this habit, you will your concept or DSA logic will be very good. So these are the patterns. First of all, we will discuss the questions. Then we will discuss the questions in very details. Like we will do pseudocode. I will explain the question solution in very detail. After that, we will write the code. And after the code, if there are any type of confusion is remaining, it will get clear after the dry run. And we will dry run every questions in very detail. Okay, so questions I have picked today is leaf at same level. Okay, we are going through the questions. Given a binary tree, check if all the leaves are at same level or not. Okay, this is the example. In the first examples, a root node is 1, its left part is 2 and 3. And we are saying that the leaf node are at the same level. That means if we are considering root as 0, and these are one. So all the leaf node. Do you know what the meaning of the leaf node? Actually, the end node, the where the end, where the nodes end, we call it as leaf node, or we can call it as last element of any like this structure, last node. We call it as leaf node. Now we will come to the example 2. In example 2, we have given a root node as 10. Its left element is 20 and right element is 30. Again, the left element of 20 is 10 and right element is 15. And we can clearly see here that all the leaf nodes, right? These are the leaf node. These are the leaf node. These are the leaf node. So all the leaf nodes are not at the same level. Like this is the 0. This is the level 1. This is level 2. Some leaf node are at level 1 and some leaf node are at level 2. So we'll return output as 0. And yes. Okay, your task. You no need to read input or print anything. Complete the functions. Check which takes a root node as input parameter and returns true or false. Okay, you have to return true or false. And every other things is going to be handled by the driver code itself. And you have to try to solve this in the time complexity of big of 1, and space complexity you can use is the height of tree, and constraint is 10 raised to the power 5. And you can see that this is one of topic tags, many company tags. Yeah, this question is asked in Amazon. So this is a good question. Coming to topic tags, this is the topic tree and data structure. Okay. Now I will discuss what should be our approach to solve these questions. Now we are going to on our whiteboard so that I can explain you all the questions in very detail. Okay. Suppose we are taking a tree. We are taking a tree. Root node is 1, left element is 2, this is 3, this is 4, this right node is 5, left node is 6, so right node is, we can take it 7. Okay, this is the tree, and from the picture you can see that this is the you can see that actually this trees uh, the leaf node of this tree are at the same level. You know that this is the leaf node, this is the leaf node, this is the leaf node, and this is the leaf node. And all these nodes are at the same level. That means if you are considering this as 0 level, this as 1 level, this as 2 level, so all the leaf nodes are at the level 2. Okay. So we are clear that the answer of this question will come as true. Yeah, all the leaf nodes are at the same level. Okay. Then we will discuss what should be our approach. Our approach is that first of all we will create a set. Suppose that this is asset. Okay, and we have this left element. We will traverse. We will take root. We have 1, and we will take height as level as 0. Level or height is 0. Then we will move to the left of this. This is 2, and now our root node is 2 while our height is 1. Okay, then from here we will move to the left again. We will reach here. Okay, and here the root node is 4 and height is 2. Okay, after this uh, there is nothing, no values, so return we will return to 2, and we will put this value when our left node and right node is null. We'll put the height, save height in asset. So we will push the height in asset, which is 2. Now we will return back to 2. We have returned to 2, and here root node is 2 and 1. We will come to the right from 2. We will come to the right, and here the root node will be 5 and height will be 2. Since after this the values are null, so we will save 2 and height as 2. And you know that in the hash set it is store only the unique value. So 2 is already present in our stack. So uh, no other 2 since duplicate value is not allowed in 2. So no extra 2 will be updated. If the height of the value will be different, it will get added. Otherwise, it will not get added. Okay. So from here we will return to 1. Here root value is 1 and height is 0. From 1 we will go to the right. Here we have root node as 3 and here height will be 1. From here we will come to the left where root node is 6 and height is 3. Since after this the values are null, so it will add height 2 in the hash set. Since again it is similar, no any update, it will return to 3. And again here root node is 3 and height is 1. From here we will come to the right, and here root node is 7 and height will be 2. And after this the values are null, so we will add height in the set. Again the values are same, so it will not added, and only 2 will remain. And at last, if we check if the size of the hash set is 1, that means all only height 2 is returned at the end, then all the leaf node are at the same level. Otherwise, if the hash size of the hash set is more than 1, that means if 1 is also there, that means our leaf get ends at level 1. That means all the leaf are not at the same level. So it will return false if the size equals to 1. It will return true. If not equals to 1, it will return false. Okay. Now I'm going to write the code and it will be more clear to you. If again it will not be clear to you, I will just do the dry run for all of you. Okay. We have given a root node. Okay. Before all this, we have to create a hash set which we will use. So we are going to create a hash set of value integer, and we'll name it as uh, hash is equals to new has hash set. Yes, we have created a hash set with name hash, which will store the integer value. And coming to the Boolean function check, we will write that. What we will write? We have to check. We will call the functions height, since we are going to save our height. So we will create a function height, and we will pass root, and we will pass initial height as 0. Okay, and the value we will get from here if set dot size equals to 1, then it will return true. Else it will return false. Now we will create height and so, public. We have to not return anything. Void left. We have to only call the values left, which HAGST height, and we have pass node root and height as 0. We can write here in height as h. Okay, and we will write the base condition if root equals to null, then simply return, and one more edge condition if root dot left equals to null, and root dot right equals to null. Uh, if this condition is happening, we will add the height in our set dot add h, okay, and we will return. And for that, we will call the functions. We will call first heigst height root dot left comma h. We will add the label. Similarly, heigst height root dot right comma h plus v. Okay. Now we will compile. Let me clear. It is showing some compilation error. The problem is in if set. Oh, sorry. The name is mm, as dot change. Again error. There is the problem. Sorry. As dot. One more problem where spelling mistake. Oh, sorry. Yep. Let me submit that. Yes, all the test cases are passing. Test cases out of 1033 test cases out of 1033 are passing. And yes, we have submitted these questions. Let me do a dry run of these questions so that it get more clear to you if you have any type of confusion. Let me create new tree. I will create a new tree for all of you. And, okay, just let me create same tree, that is 1, that is 2, that is 3, 4, 5, 6, and this is 7. Okay. Now we have created a set as set of name as, and we will add values in. We will actually add the values of height in this. And you know the properties of has set store only unique values. It doesn't store the duplicate values. So we are we are passing the root as 1 and the initial height as 0. From here you can see that initial height is 0. Okay. So first of all, we will pass our initial root value 0 and let me use different color. And this is 1 0. Now we will let me mark 1, 2, 3, 4. 1, 2, 3, 4. Here first statement is done. Second, that root is not null and this left is also not null. We are done with statement 1 and 2. And now we are at statement 3. We are calling left. So we are reaching to the left and here the root value will be 2 and height will be h plus 1. Okay. And again, first statement, root is not null, left is not null, and we are reached at statement 3 and we have passed root dot left. Root dot left is actually 4 and we will add height as h plus 1 or 1 plus 1 that is 2. Okay. Here we will reach to statement 1. Root is not null. Second, we have done with statement 2 also. Root dot no. Here root dot left is also null. Root dot left is null and root dot right is null. So we'll add the height of h in the hash table, which is 2, and we will return. So we will return here with 2, and since 2 after 3, fourth statement will execute it, and we will reach here. Here root value is 5 and height is 2, 1 plus 1. Okay. So first statement executed, root is not null. Second will get executed and it will it left is null, right is null, condition satisfied. So it will add height. Height is 2. Since hash set doesn't store duplicate value, so 2 is already there, and we will return. And it will return to from here. It will return to 1. Okay. At the 1 we have done with a statement line number 3. We will come to line number 4. In the line number 4, we will go to the right. Here root dot right is 3 and height will be 1. Okay. Here we will go to the first statement, root is not null. We will come to the second statement, left right is not null. Now we will come to the third statement, which is left. It is calling left. Yeah, here left, here it will pass root value as 6 and let me write this root 6 and height will be 2. It will first statement, the root is not null. It will come to the second statement. Yes, it satisfied. Its left and right is null. It will add the height. Yeah, since 2 is already present in the hash, it will return to 3. It is returned to 3. From 3, it will execute 4. It will reach to the right, and when it will reach to the 7, it has root value 7 and height 2. First statement get executed, root is not null. When it reaches to a second statement, yes, condition satisfied, left right is null. It will return add height 2. Okay, and it will return. It will return, and since when we'll come to this line here, we will check hash dot size equals to 1. Since only one is element is stored, which is true, and we will return true. I think that this question is clear to you. Guys, this is my first question and I think that I am able to explain you very clearly. If you are able to understand this solution, give a like. Yeah, that's all. Bye bye. Have a nice day.